All right, now in the previous example, you were given a vector and its components, and you were asked to find the magnitude and the direction. We did a little SOHCAHTOA. Well, with this one, it's sort of the reverse of that. And what we're given now, instead of the components of the vector, is we're given its magnitude and direction, and actually asked to find those components. So what I'll do then is I'll go ahead and draw a little picture here so we know what we're talking about. We know that our vector is going in the direction 163.74 degrees. Okay, well that means that if that's 0 and that's 90 and over here is 180, that means that we're somewhere over here-ish. Somewhere over here-ish is going to be 163.74 degrees. All right? Or that if we start over here and we work our way around, what we've got is 163.74 degrees. And then we also know that this is apparently has a magnitude of 25 or a length of 25. So I can say that has a length of 25. And what we're being asked to find are the components. So we're being asked to find the x component, and we're being asked to find the y component. Okay? So actually, it's just another SOHCAHTOA problem. If I know that if I start at 0 and go all the way around, I get 180, and I'm already using 163.74, that means that this angle right here will happen to be 16.26 degrees. All right, so what I have then is that's 25, that's 16.26 degrees. Here is an unknown. Well, guess what? This is a SOHCAHTOA problem again, where here is the hypotenuse, here is the adjacent side, and so I can use cosine. I can say, all right, the cosine of 16.26 degrees is equal to the adjacent side divided by the hypotenuse. Stick a 1 under here, now I have a proportion. I can just multiply. 1 times x is x. 25 times the cosine of 16.26 degrees. And if I go on my calculator, I find that x is 24. All right. If I redo this again, and I'm trying to find the y value over here, let's say now I want to find the y. That, of course, is the opposite side. I still know that 25 is the hypotenuse. This time, instead of using cosine, I can go ahead and use sine. So the sine of 16.26 degrees is equal to the opposite side divided by the hypotenuse. Again, I'll put a 1 under it, cross multiply, and I find that y equals 25 times the sine of 16.26 degrees, or that y equals 7. All right, so that means that y is 7, x we found to be 24, which means that our vector, the original question said, what is vector q? Well, here is vector q, it's there in black, and we know that we went negative 24 units in the x direction, positive 7 units in the y direction. So I could say that vector q is negative 24, 7. There is my final answer written in component form. And to get that, all we did was created a right triangle and did some SOHCAHTOA. Okay, please move on to the next slide where you're going to be asked to do problems very similar to this.